Assalamu alaikum respected faculties. I am Surid Imam along with my thesis mates Mahbub Haque, Rehnuma Binta Shahriar and Suptirani Saha will be demonstrating you about how the idea of computer-generated artificial life model algorithm came into our mind. In nature, predators have to effectively hunt the prey for their survival, whereas prey are more likely wants to stay away from the attacks of nearby predators. So the animals stay in groups to stay safe from the attack caused by these predators. For example, the natural phenomenon of hunting deer by the wolves are rare to find. Moreover, while surfing on the internet, we couldn't figure out any of the videos representing this phenomenon for of a deer and wolves, which inspired us to think how this phenomenon could be simulated in on a controllable environment by giving us the opportunity of changing the behaviors of the prey and predators externally to inspect the impact occurring due to the behavioral change. These behaviors of prey and predators for ensuring their survival can be simulated on top of the work by Craig Reynolds, where he's proposed several rudimentary rules that can be created flocking behavior as seen in nature. And to reach our goal for simulating an interaction between animals in nature, we had to simulate a deer herd trying to escape from the attack of a group of predators and how predator force some prey to isolate and capture by them, where we can see deer as prey and wolf as predator, and the movement and the communication between the wolves of an wolf pack while hunting. Since the whole dynamic of movement are governed by intelligence, elements of artificial intelligence have been applied in the program to simulate the behaviors of prey and predators, applying their intelligence for reaching their goal. For that, artificial Boyd algorithms have been applied to the movement of predators like wolves in hunting prey like deer. Though the objective of our goal is not limited only to prey-predator behavior simulation, although it can be used in many other places, where the further information will be described by my fellow mates.
Now we are going to talk about the algorithm that we use in our simulation. We use three flocking algorithms: cohesion, separation, and alignment. At first, we use the cohesion algorithm, which implements the behavior where boys try to move towards the average position with the whole group. This behavior makes the flocks stay together and the flocks cannot distract apart. Then we use the separation algorithm that implements the behavior where all the boys move maintaining a certain distance with the whole group. Because of this behavior, flocks can avoid crowd along the local flockmates. Lastly, alignment algorithm, which implements a behavior where the boys move in the same direction. It ensures the direction of all the boys are same and they are moving in the same direction as a group. Then we will add the three flocking algorithms and make a force algorithm FT. After that, we will find the minimum force F, comparing FT and the maximum force Fm. Now we will normalize the force by dividing it with the void's mass. By dividing it with the mass, we will get the velocity of the voids. Now we are going to talk about the predator escaping algorithm. Prey try to keep a safe distance from the predator, which sets a safety range. If a void or prey detects any predator in its safety range, it changes the direction and starts moving opposite of the predator's position and increase its moving speed. Next, algorithms will be described by Mahbub Haque.
Thank you, Rehnuma Binta Shahriar. Now we will going to talk about the neighbor detecting algorithm. We are using the neighbor detecting algorithm to detect who are the neighbor of the void. To detect the neighbor, void B use the visual range. Here we can see a yellow triangle indicates void B and black circle shows the visual range of void B. Inside the code, an array is used to keep the neighbor's information. This information helps in cohesion, separation, and alignment process. Now we are going to talk about the predator's algorithm. we introduced 3 new algorithms to implement predators' behavior. First, we are going to talk about the target selecting algorithm, uh, which is implemented for the leader of the predators. By analyzing prey speed and position in a given range, the target is selected. Here, the prey with the green circle is the target. Next comes the formation creating algorithm. Formation creation step allows to create formation for the predators. Using this formation, predator tries to isolate the target from the herd. From the idea of convexal algorithm, we developed this step. Another characteristic of predator is chasing. Predator chases the target according to its position. Chasing allows to create formation and catch the target. Now, rest will be presented by Rehnuma Binta Shahriar.
In the result of the simulation, we can see predators have two states. At the beginning, the predator cannot select a prey as a target. While searching the targeted prey, the predator stays in an inactive state with a minimal speed. On the other hand, as the predators are moving in a minimal speed, or you can say not moving, the preys are also in an inactive state. Here, the big red arrow indicates the leader predator, and whereas the red big black arrows are the other predators which follows the leader predator. And lastly, the small arrows indicates the prey. Here we can see in the starting of the simulation, preys appear in a circular path which is close to our initial idea. We have implemented an equation for creating a circle. Otherwise, they would appear in a random position inside the environment. Next comes the active state. After selecting a prey as target, the predator goes into their active state. In this state, the predator moves at a maximum speed and tries to hunt the targeted prey. As the predator starts to hunt the prey also goes into the active state and starts to move to save itself. The next simulation results will be discussed by Mahbub.
In this slide, we can see a snapshot of simulation where predator is chasing prey. It distracts the prey and breaks the group, which help predator to select a target. Next, we see predator are making a formation around the target, where the sky blue colored prey is the target. This formation helps to isolate the target from the herd. After isolating the target, predator catches the target and terminates it, which has been shown with the black colored prey here. In this slide, we are going to talk about some real-life implementation scopes of this thesis. The first scope is fire exit determination of a building or market. By simulating a fire scenario with the flocking algorithm, we can determine which will be a better place for fire exit. Another scope can be controlling riots. Here, the law enforcement unit works like the predator of our thesis. By simulating these characteristics, outcome can be predicted, which helps the law enforcement unit. Also, these techniques can be used in modern warfare. These algorithms can also be used to predict where a gathering can occur and can be prevented. As COVID-19 virus spread extensively in densely populated area, preventing gathering will also prevent the spread of COVID-19 virus. Locust attacking path can be predicted by using flocking algorithm and machine learning. If locust moving pattern and path is known before the attack, steps can be taken and losses can be prevented. Now my teammate Surid will talk about the conclusion of our thesis.
In conclusion, it can be said that the desire to learn about the nature and the environment in which we live drives us to explore wildlife. But this exploration becomes the reason for endangering natural life. In order to observe these rare phenomena, One must be in a particular location at a specific moment, which is most of the time is impossible. The behavior of the deer herd was implemented using modified flocking algorithm. Also, multiple wolves and their leader was implemented with their predatory characteristics using some algorithms. All these implementations was possible in the Godot game engine. The concept of the convex hull was studied for implementing the predator's formation grading behavior. After the simulation was appropriately implemented, we ran multiple experiments. Every time we saw some variation in the results, which is similar to the natural phenomenon. The most exciting part of this experiment was changing the parameters value, like the speed of the predator and prey and visual range of the entities. This allowed us to create a different scenario from the system. This whole experiment aimed to learn about the artificial life intelligence and use that in a computer-generated environment. Along with that, flocking, escaping are natural behaviors. We can observe them in our everyday life. We are also a part of these characteristics, making a vast scope for future work on this thesis. Problems related to these natural behaviors can be found from time to time, and solutions can be introduced with the help of simulation prediction that are similar to the work we have done. Thank you.
Now we are going to see a recorded video of the simulation of our experiment. After starting the video, we can see the predators are moving at their minimum speed. In this position, they are in inactive state, as they did not have selected the target. Next, we can see the predator goes into the active state with their full speed, because they have selected their target, which is the sky blue colored prey. In this position, we can see the preys are making a half circular formation to isolate the target. Here we can see the targeted prey has been terminated, as it has transferred to the black color. Now my teammate Suptirani Saha will continue with the rest of the presentation. Thank you.
Assalamu alaikum. In this part, I will discuss 5 most important reference paper which we have used to simulate our thesis paper. Flocks, herds and schools, a distributed behavioral model is the very first paper by Reynolds on 1987, which approaches based on simulation as an alternative to scripting the parts of each part individually. A flock means a group of some animals, and flocking behavior is the collective motion by a group of self-propelled in details. Hence, in this paper, Reynolds describes the flock of flocking model consisting of 3 steering behaviors, which is separation, cohesion, alignment. Mathematical models and computer simulations can emulate these flocking behaviors. However, in our thesis, we have used Boyd's algorithm. Also, we set the moving rules for each prey individually, which helps to simulate the flocking behavior. In the second paper, Boyd's with a fuzzy way of thinking by Bezek and others describes Reynolds-Boyd's algorithm with fuzzy logic in their paper. Fuzzy logic is an approach for computing based on degrees of truth rather than the usual Boolean logic on which the modern computer is based on. In the paper, they showed that animals form groups for survival and food. So, forming a group depends on the predator's behavior and the type of food source. We used fuzzy logic to get a more accurate and realistic simulation, implying the individual prey's observation and analytical capability within a range. Autonomous Boyd by Hartman and Benes added leader and eccentricity with Reynolds Boyd's algorithm in their paper to make the flock's movement more efficient by combining the steer function with the center of density and position vector. We can find the initial state and calculate the stable position of the Boyds in a particular environment. As per the paper, the Boyds without external force means a leader will have an optimal configuration in three-dimensional space, stay still, or form some visual patterns, which we have used in our prey and predator model to make it more effective. On the identification of the convex hull of a finite set of points in the plane is a paper by Jarvis where he describes how the notion of convex hull is useful in identifying the region that is occupied by a group of prey. Jarvis provided the first algorithm for computing the convex hull of a set of points, which is the smallest convex polygon covering all the points in a space set, which we have used to set boundary for our simulation. And finally, survey paper on swarm intelligence by Vijay Kumar and others published a paper about ants, bees and birds, collective behavior that represents the collective behavior of decentralized self-organized systems. PSO mainly concentrated on the math's basic theory which uses a fitness function and scores all the solutions by iteratively optimizing which reaches its goal. In conclusion, we use swarm intelligence to effectively reach our goal. That's all from us. Thank you, honorable faculties.